Now that we've explored factoring, we're going to start looking at some special cases. And the ones that we're going to focus on today involve perfect squares. So number one, the expression x squared plus 10x plus 25 is a trinomial square. What makes it a trinomial square is when you actually factor it, you get two identical binomial factors, and we'll see some more examples here in a minute. Number two, the expression 9x squared minus 16 is what we call a difference of squares. Difference because it's subtraction. Squares because we have both terms are perfect squares. 9x squared is a perfect square because 3x times 3x, and 16 is a perfect square because of 4 times 4. Number three, the expression y squared plus 81 is a sum of squares. Sum because it's an addition problem, and squares because both of the terms are perfect squares. Y squared is the result of y times y, and 81 is the result of 9 times 9. When no factor can be factored further, we have factored completely. Sometimes when you're factoring, you actually have to do multiple methods, such as you might have a GCF and a difference of squares, or a GCF and maybe you have to factor a trinomial. Lots of different situations there. So let's actually look at some trinomials and see about factoring. Now you don't have to recognize right away that they are perfect squares because eventually you're just going to be given a list and you're not going to be told that they're perfect squares or trinomial squares or difference of squares. The directions are simply going to say to factor. You can factor these the same way that we've been factoring. If you like to use the guess and check model or the FOIL model, then that'll work. If you like the box method, then that'll work. But you always want to look for your GCF first. So if we look at number 7, I have x squared minus 6x plus 9. I do not have a GCF. I tend to like to do guess and check, especially when I have a coefficient of 1. And I really don't have to do guess and check because I need factors of 9, which are 1 times 9 and 3 times 3. I need factors of 9 that add to be negative 6. Well, definitely will not be the 1 and 9, and I can get positive 9 when I multiply if my signs are the same, and I can get negative 6 when I add if both my numbers are indeed negative. So what that means is my factors are going to be x minus 3 and x minus 3. We can also rewrite this as x minus 3 squared. And this is why it's called a perfect square trinomial, because when you factor it, you get x minus 3 squared. There is a certain algebraic pattern there. If you recognize the pattern, then you can use it. Otherwise, you can just still factor the same way we've been factoring. Number 8, again, we can factor the same way we've been factoring. Keep in mind, we like for our terms to be in descending order. So I would rewrite this as x squared plus 12x plus 36. Then, because my coefficient, or my leading coefficient, is 1, I know that I need factors of 36, which are 1 and 36, 2 and 18, 3 and 12, or 4 and 9, or 6 and 6. I need a factor pair of 36 that will add to be 12. Well, that's going to be 6 and 6. So what are my factors? Well, my first terms of each binomial has to be x, and we're going to follow that up with x plus 6, or we can write that as x plus 6 squared. So again, that's a perfect square trinomial because when we factor it, we get two exact same binomials. So now let's try this last one. We have m to the 4th plus 10m squared plus 25. The nice thing is I still have just a leading coefficient of 1. Now, my first term is m to the fourth. So how do we get m to the fourth? Well, that's going to be m squared. And how do we get the 25? Well, positive 5 times positive 5. Or it could have been negative 5 times negative 5, but I went with the plus because I needed them to add to get 10. So my final answer on this one is m squared plus 5 squared. Final answer. Okay, let's look at a different type of problem here. We no longer have 1 as a leading coefficient, so I need to look to see, is there a greatest common factor? That's the first thing you always want to look at, and there is. Looks like I can pull. So when I pull the 4 out, I'm left with 4 times p to the fourth plus 16p squared. Oops, got a little crazy there. I didn't factor out my 4. It would be 4p squared plus 4. So we did a GCF there, but now we need to factor completely because that trinomial will probably break down. Now, it's not a for sure thing that'll break down, but you still want to investigate that possibility. The first term of my trinomial is p to the fourth, so I know that that's going to be p squared, and p squared are going to be my first terms. My second sign is a positive, which tells me my signs have to be the same. And since my first sign is also positive, that tells me that both of my signs have to be plus signs. Factors of 4. Well, we have 1 and 4 or 2 and 2, but we need to add up to get a positive 4, so it must be 2 and 2. So final answer would be 4, that was our GCF, and p squared plus 2, and all of that squared. So let's look at an example that has 2 variables in it. We still use the same processes. There is not a GCF among all 3 terms, so let's just look at breaking this down. There's only one way to get x squared, that's x times x. 16y squared, well, for the number part, it could be 1 and 16, 2 and 8, or 4 and 4. Now remember from a previous lesson, I always recommend that you start with the numbers closest together, and since we are dealing with perfect squares in this particular lesson, then you should be looking for that 4. So we have 4 and 4, but we also have that y squared. Well, how do you get y squared? Well, that's a y times y. And since my second sign is a plus, that tells me my signs have to be the same. And since my first sign is a minus, that tells me they both have to be a minus. So my final factored form would be x minus 4y squared. Let's try one more. We have 81a squared minus 18ab plus b squared. Again, whenever you see the perfect squares, you should zero in on that. There is not a GCF among all 3 terms. We can go ahead and just start breaking this down. 81a squared, well, that would be 9a times 9a. And our last term is b squared, so that would be a b times b. Since my second sign is a plus, the first sign tells me they both have to be the same. The first sign tells me they both have to be negative. And again, you might want to double check on this and just do your outers and inners to make sure they do combine to be the negative 18ab that we're looking for. So if I do my outers, I get negative 9ab, and if I do my inners, I get negative 9ab, which does combine for my negative 18ab. So final answer is 9a minus b quantity squared. Final answer. We have just a few more. These are what we call difference of squares. Notice they're not trinomials, so they're not going to, you might think, well, maybe they don't break down into two binomials, but actually they do. And you worked through some of these in the previous chapter, but you were multiplying them together. And then the result was just two terms. So how do these factor down? I think these are the easiest ones to factor. They are still going to break down into two binomials. How do you get a squared? Well, that's a and a. How do you get 81? Well, that's 9 and 9. The reason why there's no middle term is because when you do FOIL, the two middle terms cancel out. What that means for us in our factors is one must be a plus and one must be a minus. Oops. And if you check your outers and your inners, here you would get a negative 9a, and here you'd get a positive 9a. And that's why there's no middle term. So difference of squares always break down into two terms with opposite signs. So there is no other way to write it. It's just a plus 9, a minus 9. Final answer. All you have to do is recognize that they are perfect squares and it's a difference of squares. 21. I would probably rewrite this one with the variable coming first. So y squared and then your minus 100. It's easier to see. Now when you factor it, you get y for your first terms. What's the square root of 100, or what times itself is 100? That's 10. One's a plus, one's a minus. Again, the easiest ones, I think, to factor. Let's try one more. 64x squared minus y squared. Again, everything's perfect squares, and it's a subtraction, so difference of squares break down. 64x squared would be 8x and 8x. Y squared would be y times y. One's a plus, one's a minus.